jailbreaking TOR session using the new feature of HTML5. So, first thing first, who am I? My name is Marco Bonetti. I'm an Italian security consultant working for Cataway. Here are my mail address and the company site. I'm also a member of Slackware Linux Project Italia, the Italian part of the Slackware Linux project. Here are my contacts over there. I'm part of the project because I've ported Slackware to the PowerPC architecture. And when I'm not working for Cataway, when I'm not taking PowerPC stuff, I'm a great TOR user and research. And here are my pointer for that part of my life. So what we will see now, we take an intro, then we take a look at all HTML5 related stuff, and we close the talk with some ideas. Okay, the intro part. Who does not know what TOR is? Okay, cool, yeah. We can skip this slide, but just give you some insight. Okay, everybody knows that TOR is a network of virtual tunnels, and it's used to improve privacy and the resistance against tracking attack. And how does it work? Your connection gets bounced around the world on an overlay network built on top of the internet using the onion routing technique. And there's a lot of cryptography involved, so your connection are safe and your secrecy is protected. When you start TOR, however, you can see this warning, which say this is experimental software. Do not rely on it for strong anonymity. Why? Because TOR does work very well when you are just trying to set up a TCP connection, but there are some problems when you start adding stuff on top of TCP, and we'll try to exploit this problem right now. So, what does HTML5 provide to us? The first thing worth to mention, is client-side storage. What is client-side storage? If you want to read a cool insight on client-side storage, I'll point you to Alberto Trivero's work. He did some great work on client-side storage. I've taken his ideas and I ported it in the onion land. What does client-side storage offer? It offers session storage, local storage, and database storage. And it's the storage part of the browser experience ported to the client side, not to the server side. So how does session storage work? What is it? All of the storage, the client part, the client side storage, it's like cookies, but on steroids. They are better cookies. The session storage is bound to the web application domain, like the cookies. It's bound to the currently opened window, and it's lost when the window is closed. It's a session, all right? Local storage is very similar to session. It's bound to the web application domain, so like cookies, but both of them offer more space than cookies. And local storage can be accessed from any browser window, not only from the currently opened one. And the local storage is destroyed only by the web application. Data persists when the browser is closed, like cookies, but better. Database storage, the same thing. Bound to the web application domain, full client-side relational database controlled by web application, and it's persistent. And, well, right now is only available in Safari. You can download Google Gears, which I think will provide you some kind of database storage, but the native built-in database storage is only available in Safari. So, how can we abuse client-side storage in the onion land? All know attack vectors still apply. There are a lot of cool things you can do with the client-side storage. SQL injection. You can inject the client and not the server. Or you can do whatever you want with this kind of technology. Here, when we are browsing the onion land, data persistence is a key issue because you can leak your privacy. There are already rogue exit node which can steal your cookies or do bad things to your browser session. They can leverage these old attack techniques to a new level, like they can inject code to manipulate your data, or they can inject code for transmitting your client-side storage data to an attacker server. But we are lucky, because if you want to access client-side storage, it's all JavaScript-based. So if you run Firefox and you run TOR button, you are safe. They are a good defense. Next to client-side storage, there are offline web applications. They are really tied with client-side storage. HTML5 will standardize the possibility to save a web application in your browser cache. So you can use the web application while you are offline. Then you come online and you sync the modified data, the locally modified data with the online data. There are rules, strict rules, to prevent tampering with the offline web application installation. I have to say that this concept is not very new, because Firefox 3.0 introduced the offline event, and Google Gears and the Dojo offline frameworks let you build offline web application using Firefox offline events. And as you can imagine, storing a web application in the browser cache is very tied up to the client-side storage. How can we abuse the offline web application? Well, there's a leak of privacy if we don't do a transition between online, offline, and TOR and non-TOR states if we don't do this transition safely, or we do not properly handle the transition. We require a strong separation policies, like TOR button already does with the protected cookie jar. What TOR button does is, when you enable TOR button, it will just forget your currently non-TOR cookie jar, and it will create a new cookie jar where it will save all your TOR cookie. So TOR cookies and non-TOR cookies are physically separated. And we need the same thing when offline web application will be publicly available to all and built in every browsers. Because it's easy, if you don't do this physical separation, you can leak data in a TOR and non-TOR states, and this is not good to your privacy. I have to say that even offline web applications are strongly JavaScript-based. So the same rules of thumb apply. If you run with Firefox and TOR button, you can block most of the attacks. But on the other side, they won't probably work. The web application won't probably work. So let's go on. There are the custom protocol handler. They are old stuff, but HTML5 will standardize them. I've described them as Web 2.0-ified version of an old concept. You know that when you click on a link and the server will give you a file together a MIME type, which is not the plain HTML, your browser will ask you what to do with that kind of file, so it will remember the next time you click on the same kind of link, what to do, like opening an external program or downloading the file or whatever. HTML5 say that, okay, it's cool. You can use web applications to do that. So when you click, I don't know, a JPG image, you can open it with Flickr, for example. It uses JavaScript technology, which is available since Firefox 3.0. And this is a kind of attack. We use this piece of JavaScript, which is a register protocol handler. I hadn't much fantasy, so I call the MIME type, the type of the application, the TOR. And I provide a web application URL, which is attacker.com, and a description, the TOR handler, okay? Then I present the client with this kind of URL, which is the TOR and a unique ID. So if the browser registered this kind of protocol handler, it will use that this URL, this one. How can we abuse it? Well, between exploiting a privacy leak when switching between TOR and non-TOR states without clearing out the registered custom protocol handler, we could do a cool thing, which is tapping the unique ID we provide to the client together with a 302 redirection and the CloakNet style DNS server. Why we need this kind of stuff? Because when we use this piece of JavaScript, the register protocol handler, we cannot provide any domain. We have to provide the same domain where the JavaScript is served. So this page is hosted at attacker.com, and we have to use attacker.com in the register protocol handler function. So what we do when the client visits this URL with the unique ID, we redirect them with a simple HTTP redirection, maybe, I don't know, to uniqueid.attacker.com, and we use the CloakNet style DNS server to try to get the real user IP. If you don't know what the cloak.net is, it's a site built by H.D. Moore, the guy from Metasploit, and he's hosting several tools to broke TOR sessions. And one of these tools is a particular kind of DNS server, which well, answer you with the external IP address of the client, which is asking something to this kind of DNS server. Pretty strange. There are any defense? Well, again, we need JavaScript. This time we need only one function. TOR button permits this kind of JavaScript function. It does block only a subset of all the JavaScript function. If you want to be really safe, play TOR button together with NoScript, because NoScript will let you block everything. However, TOR button does not block this kind of function because, well, the end user have to accept to use the new protocol handler. It's not automatic. There will be a warning on top of your Firefox which say, hey, do you want to use this custom protocol handler? Yes, no. And the latest version of TOR button adds a nice defense mechanism, which is this. I was browsing to the slackware.com site. I click with TOR. I click on the install DVD #1 ISO, the torrent file, and this message pop-ups, which is asking me if I really want to load the external application to handle this kind of MIME type. I click yes, okay, launch the application, and the download manager of Firefox pops up. Yeah, it's nice, but I'm going to ask you, when you see this kind of next screen, who will not press cancel? Everybody press, okay, yes, yeah, right, let me download it. Okay, another feature of HTML5 is browser geolocation. This is not, strictly speaking, this is not part of HTML5. It's the ability to tell a location-aware web application where you are, so you can just stop toying around with your PDA, with your iPhone, and take a look around and see what there is around you. Anyway, it's quite cool, and it needs to know where you are. Geolocation it's being pushed right now into all mainstream browser, and hopefully information sharing is optional. There is this is a screenshot of Firefox. I wrote up a custom test page at my site, and it's asking me if I want to share my location with the site or not. Where does the browser, the web application the browser takes the data to send to the web application? First, it will look at the wireless cell data. This service was brought here to Loki.com. Later, it was acquired by Google, and now Firefox 3.5 exchange a 2-week cookie with the Google services providing geolocation. Then it could look up if there are any available GPS device, like Safari for iPhone does, or the latest beta of Firefox does with Linux and GPST daemon. As a last resort, it will use GeoIP, an old friend. How can we abuse browser geolocation? Well, it's the holy grail for de-anonymization attack. We just ask the user, hey, where you are? Okay, I'm here. So far, TOR button does not block this browser feature. I don't know why. I think mainly because this feature lets the user choose if sharing or not sharing the location. So if a user is trying to surf anonymously on the web, I don't think he is going to share his location to a web application. Maybe yes, maybe not. We are safe because geolocation with GeoIP, it's weak because it will spot the exit node position, so we doesn't really care about it. I think that TOR button will have to set geo.enable false when GPS is fully supported by browsers because, yeah, a user may click on yes, but I think it's not cool if a site will reveal our geographical location just asking us. Here are the funny stuff, multimedia elements. Okay, multimedia elements are a new form, a new evolution of some old friends. Everybody think you know and you probably already met embed and object element. They are from the older version of HTML, the 4th version. They have been confirmed in the new version, and they are used to include multimedia resources into a page. They need an attribute which is a source for embed and data for object. Type is optional. Well, source and data are used to give the browser the location of the multimedia resources, and type is used like a protocol handler to load up an external program or application or plugins or whatever. The main difference between embed and object is that embed is a bit more restrictive. I mean, with embed, you can only use, I think, flash note, maybe sound, video, something like that. But it doesn't really matter. In the past, embed and object were used to launch de-anonymization attacks against our user via external program because it was easy at the time. A user was browsing with Firefox or Internet Explorer or whatever under Windows, and he clicked on a embed links, and the Windows Media Player pops up, and bam, the user is fucked up because the multimedia player will not honor the browser proxy. So if the user were browsing with the TOR, the multimedia player not. So an attacker server could correlate the IP of the TOR session with the IP of the non-TOR session and reveal the real address of the user. What will HTML5 bring to us? Well, it brings to us some new players. They are video, they are audio, and they are source. Like the one before, they are used to describe a multimedia resource. They are cool because you can, the playback of the resource can be controlled either by calling the browser control or via JavaScript. And source is very similar to embed. Video is used to embed a video element and audio to embed an audio element. And how can we abuse them? Here's a nice attack. As you can see, we are using the video element. We are giving it a width, an 8. We are using the source attribute to locate the resource. If you are wondering what this OGG TOR file is, it's just the standard mozilla.org test og TOR for Firefox. And we are abusing this attribute, which is poster. With poster, we are using an FTP URL because TOR doesn't play very well with FTP. And we are using a PNG file. What the poster is? The poster is just an image the browser will load while it is retrieving the video resources or whatever else is here. And we are using autobuffer and autoplay. Autobuffer tells the browser just to catch the resource automatically, and autoplay just to play the resource once it's completely buffered. This is not very important, in just a text. It will be displayed if the browser doesn't understand the video element. How can we describe this kind of attack? It's broken because we do not use no external program. We do not use any JavaScript, and it's pure HTML browser de-anonymization. I did some tests. I ran this kind of attack on Windows XP Service Pack 3. I tested both Chrome 3, Chrome 4, Safari, both Firefox 3.5 and the latest beta. I did some tests running this week. And I tested the Firefox version both with and without TOR button. And I did the test both using either the Polypo HTTP proxy chained to TOR or TOR itself as a SOX proxy, because there is some ongoing discussion on the TOR user mailing list about if they should drop support to the Polypo proxy in their bundle, because Firefox play quite well with SOX without leaking any DNS. But so I test both ways, and here are the results. As you can see, Chrome will leak the original IP address because it's easy. You can't have an HTTP proxy honoring an FTP session. So the browser will just say, oh, OK, an FTP. Oh, I do not use the proxy. I just go plain. And Safari will leak. That's interesting. The current stable version of Firefox, it's safe, even with or without TOR button. And I'll explain you why. While the latest version of Firefox, the beta, it will only leak when using Polypo and without using TOR button. If you take a look on the right side of the slide, leaking is far, it's less dangerous when using SOX, because I think because the browser will just not try to set up an FTP connection when they get a SOX proxy. Safari will, and without the proxy, so it will leak. The results on the right side are in orange because I do not take DNS leaks into account. So if you are browsing TOR just using SOX, watch out for DNS, because an attacker can spy on your connection just watching your DNS queries. The current stable version of Firefox is safe by broken implementation because it does not honor the poster attribute, so you're safe. Latest beta with TOR button is safe. What does this tool tell to us? It's, well, stay with Firefox. If you are using TOR, stay with Firefox and stay with TOR button. So, next ideas. First, the bad ideas. JavaScript is the glue of the next kind of web. It's dangerous, and we have to protect ourselves when using TOR from JavaScript. HTML5 will bring nice attack vectors. Browser geolocation and all the other bells and whistles are transforming the browser into something more powerful than it was before. So we have to pay attention also to that. And I have to say that the latest beta of Firefox is showing some interesting area worth to take a look to launch a new de-anonymization attack. I'm talking here about the new fonts. They have a new font schema in the CSS. I have still to take a look to that, but it's promising. And the next good ideas are use TOR. And if you use TOR, if you like using TOR, set up a relay and stick with Firefox. There's no reason to use another browser when using TOR, because the other browsers are more easily exploitable than Firefox with Tor button. If you are using Firefox to browse Tor, stick with Tor button. Avoid any other proxy switching extension. It may sound lame, but I like giving out talks about how Tor works and how a user should use Tor in Italy. And always at the end of the talks, someone raises his hand and say, I'm not using Firefox with Tor button. I'm using it with, I don't know, Foxy Proxy. I am safe. No, you are not safe, because Tor button, it does not just change your proxy setting. It protects you from several other forms of attack. Tor button is good, but it's not enough. You can visit the torproject.org site for approved extension and some more tips to be more secure. And well, spread the word. Go out and say, oh, Tor is cool. Use it and use it safe. So, as promised to the organizer, I take the talk running. Are there any questions? Okay, no question, good. And the last bit, on the presentation, you'll find this webography with all the kind of link I've taken the material from. And this presentation has been released on Creative Commons, and that they were over there, which is seed77.slackware.it. It's already online, so go take a look, download it. Thanks.